This is Sukriti Joshi. Our today's topic for this particular video session is nuclear reactions. Okay, so this particular lecture, this particular session will involve what is the nuclear reaction. So we all know that here, that in chemistry we have different types of reactions, but two are considered as the main reactions. One which is known as chemical reaction, second one which is known as nuclear reaction. So chemical reaction actually occurs when the electrons came into picture or when electrons took part in the reaction. But when the nucleus plays a role or when nucleus came into picture, they are known as nuclear reactions. In general, when we talk about chemical reactions, then chemical reactions actually involves different or lesser energy, while in nuclear reactions we will get a tremendous amount of energy. So it is possible that while we study about such kind of nuclear reactions, right? So at the same time, we will get to know that how many amount or which amount of energy will be released when such kind of nuclear changes occurs. So such kind of reaction actually occurs when the change in nucleus will be there. So change in nucleus means change in number of protons, change in number of electrons, and that change, which is in number of protons or in number of electrons, causes the energy to release, particles to release. That particles which are released took the form of different decays, different types of radiations, and when such type of things are removed from that particular nucleus, which is known as parent nucleus, we will get two or more different types of other nucleus also. So in that way, we will actually creating another elements here. So nuclear reaction actually involves the formation of new elements, right? They are different in atomic numbers, they are different in their atomic mass. They will be changed depending upon the type of radiation, depending upon the radioactivity that it will show you. Because each and every nucleus shows you different activity. And when you get different activity, you will get different daughter nucleus, right? The parent nucleus is the nucleus which is basically, or which will give you an idea that which is the main or the unstable one. So that unstable one releases certain radiations and will give you another one which is known as the daughter nucleus. Okay. Now there are two different types of reactions. Number one, which is nuclear fission, and number two, which is nuclear fusion. So in general, as I said you, how many number of protons, how many number of electrons are actually been removed from that particular unstable nucleus, which is known as parent nucleus. We will decide that which kind of reaction will it follow. Fine. So the first one that we will take into account is the nuclear fission. So in 1939 or in 1939, Hahn and Stessman discovered that a heavy atomic nucleus as of uranium-235 upon bombardment by a neutron splits apart into two or more nuclei. That U-235, that is uranium-235, first absorbs a neutron to form an unstable compound nucleus. Now the excited compound nucleus then divided into two daughter nucleus with the release of neutrons and large amount of energy. Now this splitting of heavy nucleus into two or more smaller nuclei is termed nuclear fission. Okay, so fission means the splitting. So it is basically the splitting of heavy nucleus into two or more smaller nuclei. It will be fished off. So the smaller nuclei formed as a result of fission are called fission products. Now the process of fission is always accompanied by the ejection of two or more neutrons and liberation of vast energy. It will liberate a huge amount of energy. So given large nucleus can fission in many ways, forming a variety of products. Thus, the fission of uranium-235 can occurs in about 35 different ways. So two of this are given below in the form of equations. First one here, as you can see, that is 92 uranium-235 is bombarded with a neutron. Okay, so 0 neutron 1 will get bombarded on uranium. So it will convert itself into 56 Ba139 plus 36 krypton 94. It will also releases 3 other neutron particles. So 0 and 1 plus a huge amount of energy will be released. Now here, as you can see it in the image, what I have given you is the explanation of how nuclear fission occurs. That is a nuclear fission of 92 uranium-235. So a neutron, which is 0 and 1, will be bombarded on 92 uranium-235. As you can see, it's a huge molecule, right? So it is known as parent nucleus. Now that parent nucleus will be fissioned into two different smaller nucleus, right? So the first one is 56 Ba142. Another one is a smaller one, which is 36 krypton 91. Now in this reaction, it will give you tremendous amount of energy, which you can see in the image also, and 3 other particles of neutron will be there, right? As you can see it in the image, we have 0 and 1, 3, 0 and 1 and 0 and 1. So they will release 3 particles plus tremendous amount of energy plus 2 different daughter nucleus also, right? So here the parent nucleus is 92 uranium-235, while the daughter nucleuses are 256 Ba142 and 36 Kr91. So if we talk about the characteristics of the nuclear fission, upon capturing the neutron, a heavy nucleus cleaves into 2 or more nuclei. And 2 or more, the next one will be the 2 or more neutrons are produced by fission of each nucleus. The third characteristic of nuclear fission is vast quantities of energy are produced as a result of conversion of small mass into energy. And the last characteristic is all the fission products are radioactive in nature and giving off beta and gamma radiations. Now here in the image, as you can see, this is nuclear reaction. So let's see how it goes. First of all, 92 uranium-235 is bombarded with neutron, right? So that 92 uranium-235 is bombarded with neutron, convert itself into 56 Ba142 and another 136 Kr91. They will also produce 3 neutron particles, right? So that 3 neutron particles again carry forward that particular reaction. So they will again bombard 92 uranium-235. That 1 neutron will bombard 1 atom, second neutron will bombard another one, while the third neutron will bombard the third one. So now the fission of this 3 atom again that will be done. So they will again be completed itself, or it will convert itself into 2 daughter nucleus, that is 56 Ba142 and 36 Kr91, right? So that kind of the 3 atoms will convert into its daughter nucleus, that is totally produce 3 of Kr nucleus and 3 of Ba nucleus, plus total they will produce 9 neutron particles. So that 9 neutron particles will again carry this reaction forward, and they will again bombard another 9 uranium atoms. So that uranium atom, which is unstable in nature, again will be converted into 2 stable parent daughter nucleus. That is, one is Kr and another is Ba. That again creates that neutron, and in this manner that particular reaction is carried forward. Okay, in this manner the nuclear fission carried out. Now the next one is nuclear fusion. So these reactions take place by combination or fusion of 2 small nuclei into larger nucleus. At extremely high temperatures, the kinetic energy of this nuclei overweighs the electrical repulsions between them. Thus, they collapse to give an unstable mass which decomposes to give a stable large nucleus and a small particle as proton, neutron, positron, etc. For an example, 1H2 and 1H3, so fusion of both of this atom occurs and it will become 2He5, which is unstable mass. Now this unstable mass will convert itself into 2He4 and will releases one neutron particle, which is 0 and 1, right? So in this manner, this particular nuclear fusion is carried out. So let's take a look on what are the differences between nuclear fission and nuclear fusion. So first we will take the points of nuclear fission, another one will take a point of nuclear fusion. So a bigger, heavier nucleus splits into smaller nuclei in nuclear fission, while in nuclear fusion the lighter nuclei fuse together to form the heavier nucleus. So fusion is all about fusing of this lighter nuclei, while fission is all about fishing of the larger nucleus into smaller ones. Nuclear fission does not require higher temperatures, while nuclear fusion requires a very high temperature to fuse. Okay. In nuclear fission, a chain reaction sets in, while in nuclear fusion, no chain reaction will be there. Nuclear fission can be controlled and energy released can be used for peaceful purposes, while nuclear fusion reactions are not controlled and energy released cannot be used properly, because it's all about a fusion, right? In fission, you get a typical type of energy. The products of nuclear fission reaction are radioactive in nature. The products of fusion reactions are non-radioactive in nature. At the end of nuclear fission reaction, nuclear waste is left behind, while no nuclear waste is left behind at the end of nuclear fusion reactions, right? So if we talk about that, then fusion is basically an eco-friendly one, while fission is not eco-friendly one, right? This is all for this session. Next we will see in our next session. Thank you so much, everyone.